Hello everyone, welcome to the session. So in this particular video, we will try to understand the problem in very much depth. We'll try to see that what actually we want to, get in this particular project, what's the real objective. And in the next video, I will try to explain to you the solution approach for the same. And afterwards, we will start our implementation part, okay? So let's get started. I hope that in the project overview, you already have seen this particular, diagram, right? You already have been aware about this. We have seen that in a text generation, the application scope is that either we will be able to, generate the code, or we want to generate the story out of it. That's the, I would say, real objective, if I'm not wrong, right? Now, when I'm saying code generation, what does that mean? Simple meaning is that we have trained a model on a code from a scratch. Okay, suppose I will be having a model M1, and in this model M1, I have trained a code. We have trained a code from scratch to help the programmers to, write the code automatically with the help of this model M1. So it will be for the ease of our programmers, the code generation part that I am talking about. So with respect to the different coding tasks, we have already pre-trained our model so that when in future, if I require the code, my model will be automatically able to generate that. That is something which we are talking about, a code generation use case. But here in this project, we are not focusing on this particular use case, or we are not, in a way, I would say, using the, model, pre-trained model to generate the code. Our second use case, so here, this is what we can say is an application part. Application per se, if someone will ask you. So in case of application scope, you can tell that, okay, when we are talking about a text generation use cases, we either have a code generation use case or we will be having a stories generation. When I'm saying stories generation, what does that mean? Its simple meaning is, again, we have pre-trained our model M2 in such a way that it will be able to generate a story out of it, story out of the context of the sentence which a user is entering. For example, you can see, right, when a user is entering that NLP has given major breakthroughs, when we insert that in our text generation model. So this is the model M2 which I am talking about in my project. And that is what we really want to do in this particular project. So please try to understand the problem statement pretty well, because if you will not able to understand the problem itself, how will you move ahead towards discussing the implementation part or, solution approach part? So please pay attention 100% to this particular video which I am trying to convey here. So what we are saying that user will enter this as the input text. User will enter this as the input text where user will write some sentence. And this model M2, and here I will show you also, you will be sure that here we are passing a pre-trained model. Now, what do you think? What is the meaning of a pre-trained model? Whenever I hope that you have heard this particular term a lot number of times while doing specifically the projects of NLP, because in NLP, we usually deal with a lot of pre-trained models. Its simple meaning is that we already have a corpus, or we already have a huge data set on which my model is already trained on. That is the simple meaning. See, when we will be having a neural network in deep learning, what we usually do in the training process, can I say that in training process, if suppose we will be having a neural network like this, where we will be having some target value, like this one. Suppose this is a simple neural network which I have designed here. Now, when I'm saying that, okay, the training is happening, in case of deep learning, in case of neural network, what does that indicate? That indicates that there is a concept of feed forward, there is a concept of back propagation. But when we are saying that training is happening, the simple layman, understanding is that we are trying to get the optimal weights. We are trying to get the optimal weights. because I hope everyone knows that in back propagation, we are not doing anything but to update the weights, right? So here suppose we will be having a W11, right? W12 and W21 and so on. So basically here our real objective is nothing but to update the weights in a neural network, and that is something which we called as training is happening. And this process we will keep on moving until we will be able to get a minimum error. Until we will be able to get a minimum error. What is error? Error is nothing but it is the difference between the value of y and the value of y cap, where y is nothing but is the target value that we have, and y cap is nothing but is the predicted value that we have, right? So when I'm saying pre-trained model, it means that the training already happened. So we will be having a predefined optimal weights in our model. Now we will be able to apply the pre-trained model on our data that we have, we are passing as an input text, then a fine-tuning will happen. Then a fine-tuning will happen on the basis of the context which we are providing, and accordingly it will be able to generate the proper output that we want, which is a complete sentence. For example, here when I am passing NLP has given major breakthroughs, it is giving me the output as NLP has given major breakthroughs like that text classification, text summarization, text generation, text to speech conversion, etc. Right? So here now there must be a question which you have in your head, that which kind of pre-trained models we are using here. Now you will observe that in Hugging Face, there are a lot many pre-trained models that we have. A lot more. If I will show you a complete list of that, you can clearly see, right? Here, this is a complete list of transformers, pre-trained models that we have. And here, with respect to BERT, there are so many models we have. With respect to GPT, there are so many models we have. With respect to GPT2, again, we will be having GPT2 XL, GPT2 large, GPT2 medium. For every particular pre-trained model that you are using, you will observe that there is a difference in the layers, the hidden, the heads, and the parameters. So in our project, we will try to utilize the property of GPT2 large. Here, when I am saying GPT2 model, what does that indicate? The simple indication is that whenever, so we are talking about GPT2 pre-trained models, remember that this model is having a 1.5 billion parameters. This much huge pre-trained model it is, and it is trained on a dataset size of 8 million web pages. 8 million web pages. That much huge corpus it is. So this is the size of the data set. So data set size is this much huge. So make sure that you are dealing with this much bigger pre-trained model, and because of that it will be easily able to generate the text. Now for sure you must be having the question that how it will be able to generate the text. That I'll talk about a mathematical idea where the major concept that GPT-2 follows is a concept of conditional probability, I would say. Conditional probability. I'll talk about in lot much depth in the next upcoming video that why I'm saying it follows a conditional probability. And GPT-2 is nothing, or any GPT is nothing but is a layer of decoder layer of transformer. So it's a decoder based network. So if you will go to the network transformer architecture, you will see that we will be having an encoder. From encoder we will be able to get some output, and that output we are passing in the decoder to get the final output. So here if you will observe, when I am saying GPT is a decoder based network. Depending upon what kind of GPT you are using, the number of decoders will vary here, right? I hope that I am making sense to everyone, and this particular model part is also pretty much clear to everyone. Now, what are the different tasks that my model will be able to give to me. Okay, we will be able to understand that here we are talking about a stories generation, but in stories generation also, how many different types of categories that we have, or in other words, where is the application scope, where is the application scope specifically, what is the different tasks that my model will be able to generate. The very first thing that you will see is in the completion generation models. Again, that is a task that I'll show you via implementation as well. Completion generation models. So just now I have shown you that GPT-2 large model that is, responsible to generate the sentences to complete that particular complete sentence. So just now that example that we have seen, right? It's an example of a completion generation model, where if suppose I will write some sentence, for example, I'll say once upon a time, or maybe I'll say I love reading novels. So via giving this particular sentence as the input, when I am passing it inside I would say text generation model, so it will be able to give me it will be able to complete this particular sentence, because this sentence as of now is not complete. So it will be able to give me a huge lines or sentences where the major task is to complete this particular context which I am talking here. It will complete the context, right, which I am talking here. So this is one task variant where I am talking that, okay, I will give some incomplete sentence, I will pass some text generation model. So here the model that we will use in our project, which is responsible to, do this particular task, is GPT-2 large. That I'll show you when I'll share the implementation part as well. So what will happen is it will be automatically able to give me the context out of the data set, which is a huge corpus which is already been trained. The second task which it can be easily able to perform in case of stories generation is, I would say, text to text generation models. Then there are different categories of models. One category I have talked about is completion generation models, where I hope you will be able to understand that if someone or if a user will give the input in maybe incomplete sentence, it will be able to produce a complete context out of it. So this will be the appropriate output for the same. Another variant which I am talking about is the text to text generator or text to text generation models. What will happen in this particular case is, for example, I will give a complete context, I will give a complete text, but on the basis of that, I want a complete mapping of that. So here, important role which is there is mapping. Very good example. Can you think of anyone? Just pause a video and try to think that where you are seeing this kind of models. Just if you will observe in translation, in Google Translation, suppose I want to translate language translation, the language from maybe Hindi to English. So in that particular case, what I really want is, I want a proper significant mapping of Hindi words to the English words, or maybe English to France, or maybe France to Japanese. Any particular language translation, whenever we are talking about, there we will be having a one complete text. For example, I'll say in Hindi, "मैं कैसा हूँ," and then in English, the translation will be, "How are you?" So there a proper mapping is happening, right? मैं कैसा हूँ and how are you? So it will be able to generate and you will be able to give me a complete text only when there is a complete mapping out of that. So this is also a part of a generation models, but it comes under a different variant called as text to text generation models. Here, if you will see, the most popular models are, which I am talking as a pre-trained models, are T0, T5, and BUT. So these are the different categories of the models that you will see. Again, you can just refer that particular list where I have defined you the different models that we have. Similarly here, this is again a pre-trained model which I have talked about, which is responsible for the first task, and that is what I will use to generate the context to complete my sentence. So these are the application scope. Now you can see, apart from that, you will see there is a application in text summarization, right? So using different pre-trained models that we have, we can easily nowadays do all these significant tasks that we have. Apart from that, language translation just now I have talked about, right? Language translation just now I have talked about. Apart from that, we have seen text classification. So all these things are nothing but an example of or applications of what we are doing in this particular project, right? All these things will require nothing but a generative models, and there is a lot more list that I have shared with you all, where for transformers we have so many pre-trained models. Every pre-trained model is having a different sort of architecture and its application. So I would suggest go with respect to that particular web page, try to see how many different kinds of pre-trained models that we have, and I told you that what we are going to use in our project very clearly, right? Now the next upcoming part of the video, you will find out that we are discussing the description of our solution. I'll talk about the end-to-end architecture, like how the flow will go in the upcoming part of the implementation part, what we will do, what's the logic behind that. See, for any particular project, whenever you are studying, you will observe, before this I have created a project for machine learning per se, big data per se. You will observe, if you have already watched the videos of mine, or maybe some other mentor creating some other projects, one thing you will observe that the pipeline is same. The only thing that here we need to understand is the why part, the logical part, that why we are doing these things, how we are doing. If you will observe, the pipeline is completely same. We always start from data ingestion, then we will see the data validation, then we will talk about data transformation, then we will talk about model training, then model pusher, where we are directly pushing into the S3 bucket the final trained model that we have, so that in future we can do the predictions for the next particular part. But here we need to understand the application scope. Here we need to understand the solution for every particular problem statement, what's the logic behind that, and how we are solving that particular logic, what kind of models we are using. The good thing is that whether we are talking about machine learning, whether we are talking about deep learning, whether we are talking about NLP, we already have a models. We already have a models. We already have a sklearn package. We need to import that directly. But the only thing you need to understand here, that how and why the things are happening. If you're good with these two questions, you will be very easily able to understand the context behind whatsoever I'm saying here, right? So with this, let's end this video. I'll come up with another video where now we will talk about the solution description of this particular project, where I'll talk about step by step that how the flow will come, so that when we will move towards the implementation part of the videos, you will not face any trouble. I hope that until so far you are enjoying the project, and if you have any sort of doubt, you know what to do. Just mail me out, or you can just ping me on LinkedIn. I'm very much active there as well. And with this, let's end this video. Happy learning to all. Bye bye everyone, and I'll see you all in my next upcoming videos.